Hey there. You know those little sparks you sometimes see or feel on a really dry day? Well, that's static electricity. And today, we're going to dive right into the super cool world of electric forces to figure out exactly what's going on. Ready? Let's get started.
So you know how sometimes after you brush your hair, your comb can suddenly pick up little bits of paper? It's like a magic trick, right? Well, guess what? It's not magic. It's actually science. And I promise, by the end of our chat today, you're going to know the secret behind that trick.
All right, so where do we even begin with this mystery? Well, the very first clue is something called charging by rubbing. It sounds a bit technical, but it's a really simple idea, and it's the perfect place for us to start our journey.
Okay, let's imagine a little experiment. First, you take this thing called an ebonite rod and hold it near some little paper scraps. What happens? Piff, nothing. Boring, right? But what if we take that same rod and rub it with a piece of wool first? Then what happens? Well, that's when things get interesting.
And look at this. It shows it perfectly. On the left, before rubbing, the paper just sits there, not interested at all. But on the right, after rubbing the rod with wool, wow, suddenly something's changed. The paper is literally jumping up to the rod. It's like that simple act of rubbing gave it some kind of superpower.
So, this amazing effect has a name. It's called charging by rubbing, or, for a more scientific term, electrification. In Arabic, you call it at-takahrab, al-takahrab. The main thing to remember is just this. Rubbing two things together, like our rod and the wool, can give them a special thing called an electric charge.
Okay, so we know rubbing can create a charge. Cool. But does this trick work on everything? Like, could you rub a metal spoon and pick up paper with it? Good question. To figure that out, we need to talk about two kinds of materials, conductors and insulators. All right, let's break these two down. First, you've got insulators. In Arabic, that's awazil. Think of these like a traffic jam for electricity. The charges get stuck and can't really move. Then you have conductors, or muwasalat. These are the complete opposite. They're like a super fast highway for charges. They can zoom right through. And here are some really good examples. Things like wood, paper, and glass, they're all insulators. That's why our experiment with the ebonite rod works so well. But then you have metals like copper and iron. They're conductors. So if you tried to charge a copper rod, the charge would just flow right away and it wouldn't be able to build up and pick up the paper. Okay, we're making progress. We know how to charge things up. But what happens when you bring two charged things close to each other? Well, it turns out there are a couple of really simple, really important rules for how they act. This diagram makes it so easy to see. Look, when you've got two positive charges, they're like, nope, get away from me, and they push each other apart. Same thing happens with two negative charges. But look what happens when you bring a positive and a negative charge together. They pull towards each other. They're attracted. So, this brings us to the two big rules you absolutely need to remember. Rule number one, things with the same charge will repel each other. In Arabic, that's tanafar. And rule number two, things with different charges will attract. The word for that in Arabic is tajadhab. It's just like the old saying, opposites attract. You are doing an awesome job. We've covered all the main ideas now. So, you think you're ready for a little challenge? Let's do a few quick questions to see what you've learned. Let's practice.
All right, here's our first question. When an ebonite rod is rubbed with a piece of silk, which of these things happens? Take a look at the options and think about it for a sec.
Did you get it? The answer is B. The ebonite rod becomes negatively charged. And here's why. These teeny tiny negative particles called electrons, that's electronat in Arabic, they literally jump from the silk over to the rod. So the rod gets more of them and becomes negative. Awesome job if you figured that one out. Okay, next one. All of these materials will attract paper after you rub them with wool, except one. Which one is the odd one out? Is it wood, silk, glass, or gold? Think back to what we said about conductors and insulators. And the correct answer is D, gold. But why? Well, wood, silk, and glass are all insulators, remember? They hold on to a charge. Gold, though, is a metal, and that makes it a conductor, or muwassal, so any charge you give it just flows right away instead of staying put. Makes sense, right? All right, last practice question for you. Imagine you rub two balloons with the very same piece of cotton. Then you hang them up next to each other. What's going to happen? Which of these pictures shows the right answer?
And the answer is figure A. It's because you use the same cloth on both balloons, so they both get the exact same kind of charge. And what do we know about things with the same charge? They repel. In Arabic, we'd say they yatanafaru. So they're going to push each other away. You guys are doing fantastic.
Wow, that was a lot to cover, but you did such a great job following along. So before we finish up, let's do a super quick recap of the most important things we learned today. Okay, so here are the 4 big takeaways. First, we learned you can give something an electric charge just by rubbing it. Second, insulators are things that hold that charge. Third, conductors are things that let that charge move. And finally, the most important rule of all, same charges push away and different charges pull together.
Seriously, great job. You did an amazing job today. You now totally get the basics of electric forces. And hey, now you know the secret to why that comb can pick up paper. See? It wasn't magic after all, just really, really cool science. Never stop asking questions and keep it up, because learning is so much fun.